Many applications, such as surveillance records, games, and air traffic control systems require users to select moving objects, which is considerably more difficult and error-prone than selecting stationary objects. In this paper, we present two techniques to aid selection: Comet and Target Ghost. Comet enhances the target selection area by adding a tail to it, while Target Ghost creates static proxies of each target. The basic cursor has a single point of activation. It can be difficult to select a moving target, especially when the paths of the targets are not predictable. We introduce Comet, which increases the selection area. A tail is placed behind the target with a length dependent on the target speed. The tail in the 1D experiment narrowed towards its end. However, we found that since most users select the tail near its end, a larger area would be beneficial. In the 2D design, Comet has an increased activation area at its end. The tail bends and turns based on the object's movement. Targets with lower speeds have shorter tails. Targets with higher speeds have longer tails. Ghosting is invoked by pressing the Shift key with the non-dominant hand, as we see here. This creates a proxy of the moving object which users can select with the cursor. Ghosting can augment any cursor and can be coupled with other target-based enhancements. We implemented the Bubble Ghost, as well as the Comet Ghost techniques. In a video feed, we manually extracted the moving object's motion paths to demonstrate the value of our techniques. Here, a comet tail is attached to the car, and the user can select it to get more details on the object, shown in the upper left corner. Comet Ghost creates static replicas of all the objects in the scene based on their position at the time of invocation. The background becomes dimmer to show that the Comet Ghost is activated. Users can then select the motionless targets. We also implemented the Bubble Cursor and Bubble Ghost techniques to examine how they can be used in real-time environments. In our first experiment, we compared their performance in a 1D selection task. We found that participants were fastest with Comet, then Bubble Cursor, followed by the area and basic cursors. To our surprise, we found that the ghosting techniques were slower for 1D selection. We found that this was primarily due to the overhead in having to press the Shift key to create the proxies. We found similar results in the 2D experiment, and Comet required less time than the Bubble and basic techniques. However, all of the ghosted techniques allowed participants to complete the target selection task in less time than with their non-ghosted counterparts. Bubble Ghost was found to be the best performer. We have shown how novel enhancements to targets, such as Comet and Target Ghost, can significantly aid in selecting moving targets. These techniques are particularly useful for scenarios involving real-time interaction.